Guys, welcome back to Campus TV. Let's focus our attention on what electrical energy power. We are seeing what Jamb Physics class. So now Jamb is few days to go, and this class is a class to help you cover some of the most important aspects in physics, maths, and chemistry. So I'm here to do my best for you to enable you to cover some important aspect of what physics here. Do you understand? And this topic is one aspect of what electric field that come out all the time. So this is going to be the third video or the fourth video on what electrical field. I've done first three video on electric field. Can you go check out those videos in order for you to be able to flow? So when you see question in the other one, say you should be able to answer it. So we're going to start with energy, because we're talking about electrical energy or electrical power. So let's talk about energy. Now when a charge move from point A to point B, work is said to be done. Right. So whenever in a circuit, whenever a charge flows from point A to point B, work is said to be done. And the work done when a charge moves from point A to point B in an electric field is called potential difference between the 2 points. Right. So I'll come again. The work done when a charge flows from point A to point B in an electric field, it is called potential difference between the 2 points. Right. So that is potential difference related to with energy and charge. So here we can say W is which the work done times what the potential difference which is the V times the quantity of charge that flow. Do you understand? So the here called energy. So you can say energy is equals to what? Energy is equals to what? Potential difference times what? Quantity of charge. Quantity of what? Of charge. Or you can say charge. Again, you can say charge. So this one is very important here. Now there are two formulas we need to bring in order for us to solve problem when it comes to work in when it comes to electrical energy or electrical, and when it comes to electrical energy. Now the other one is going to be what? V is going to be what? Q equals to what? IT. So this is what is quantity of charge equals to what? The current that flows through the circuit and the time it takes. So it's going to be what? Charge. So charge equals to what? I times T. I is the current that flows. T is the time it takes for the current to flow through the field. You get. Now we still have another one that is Ohm's law. So Ohm's law is what? Is V is equals to what? I R. There. So these three formulas, 1, 2, and 3, they are the formulas you need in electrical energy. Depending on what you be given, that's when you can derive other formula. So I don't want to go into the derivation now. So I just want to see how you can use these things to solve questions. You get. Now let's do this little derivation here. Let's do this derivation here. Here we have W equals to what? V times. Now what is Q? Q is what? IT. So going to be what? IT. Right there. Now what is V? V is what? IR, right? So you can say W equals to V is what? IR, which is what? IR times what? T, right? So if you should which is what? IT2. IT. So what happened here? It's going to be W equals to I square R T. Very important. So these are the few formulas we can use when it comes to electrical energy. But as we move on, there's other formulas we have to derive depending on what the question can be given to us. So let me copy all these things out here. W equals to what? IQ. Q equals to what? IT. Then V equals to what? R. So these are the things we are going to make it up. So now let's start solving the first one. They say find the work done. So they say she will find the work done, right? Work done in moving a 5 column. So Q is what? 5 column, right? Charge between 2 points X and Y in an electric field. Calculate what the work done if the potential difference is what? So V is what? Is 120 volts. Right there. So which one are we going to use? Of course, we are going to use what? The first one here, which is what? W equals to what? Q VQ, which is also the same as what? Which once you put your values, 120 times 5, right? 600 what? Joules. That is what by question 1. So this is the solution what? 1. Then now look out for the solution 2. A work done, so W here is equals to what? 30 what? Joules, right? It's done in transferring 7 millicoulombs of charge. So my charge is what? 7 milliwatt coulomb. Now this milli here means what? 10 to the power 3. So going to be 7 times 10 to the power 3 watt coulomb. So that is why all those prefixes here in physics at the start of the textbook here, all those prefixes you have to know them. You have to what? Know them. So 7 millicoulomb is also the same as 7 exponential 3 watt coulombs, right? Now what they say you should look for? They said point A to point B. Now what is the vote? They say a work done, 30 joules. Yes, charge is what? Point B to point A in electric field. Calculate what the potential difference. So you are calculating what potential difference. You are calculating what potential difference. Very easy here. So remember W is equals to what? V over what? Q, right? Okay, sorry, remember W is equals to what? Q, VQ, V what? Q, right? So make it voltage cell formula here. Potential difference equals to what? W over what? Q. Can you see that? So you put your formula here, you have what? 30 joules over 7 exponential or 3 watts coulombs. So it's going to be 30 divided by 7 exponential 3. So going to be 0.00428 right volts. So V is equals to what? 0.00428 volts. That is it. Just done. So that it go there for question 2. This is that a lamp takes a current of 25 amperes. So current equals to what? 25 amperes, right? From 330 volts. So my potential difference which is volt equals to what? 330 volts, right? Calculate the energy. So here we have W, what I'm looking for, right? Energy. If calculate the energy produced in the time is what? 15 watts minutes. Right there. Now whenever you see minutes, you have to convert it to seconds, right? When you convert it to seconds, you multiply the minutes with what? 60. So my time here is going to be what? 15 times what? 60. You're going to give me 50 times 60. You're going to give me 900 what? Seconds. We can just say X seconds, right? So remember, work is equal to what? VQ, right? But Q was not given to me. They gave what? I and what? And T. But remember, Q is equal to what? IT, right? So it means that what? VIT, that is me. So then my W is what? My V is what? 330 times my I is what? 25 times my T is what? 900. So here we now have 7425000 right there, joules. So but now let's convert to what? Standard form here. So you have 1, 2, 3, 4, 5, 6. So it's going to be 7.625 exponential what? 6 what? Joules. You can see how it is here, right? So let's look at what's a set of other questions. So you know how we do it in our class. when I finish solving some questions, I would like you to try as much as possible do one on the board. So this is your first assignment. We go to the assignment one. So here we have three set of questions here. So you do the assignments, do the next session. If you're in our group chat, Jamb group chat, please send to my DM. So the next one to look at is what is power. So that let's look at what power before we end this class. Let's look at power. So let's look at what electrical power. Therefore, what's power? Power is defined as the rate at which energy is being consumed or transmitted per unit time in the circuit. So when we talk about power is equal to what? Energy consumed or transmitted per what unit what time. Right there, and the unit is what is watt. So here you can just say P is power, W is the work done over what T. Do you understand? So this work done is what we have already studied. Remember, W is equals to what VQ, right? And W is also the same thing what as DIT, right? And W is also the same thing as what. Remember, V equals to what I arrow, right? So it's going to be I arrow IT. Also, the same thing as what W equals to what I square arrow T. Do you understand? So here you can say W equals to what VQ over what T, right? Now here you can also say P is also the same as what VIT over T. T becomes out T, so here we have VI. Can you see that which is what the energy? Here we can also say P is equals to what I square arrow T. You're supposed to be T arrow T over what T, right? T becomes out T. So here we have what I square arrow. This is that. So these are things you got to know when you are solving what's power. So here we have, if you write them, here we have what W what T, right? So you almost what know the work done depending on the parameters given to you. So we can also be the same thing as what VQ over what T, right? We can also be the same thing as what VT, right? We can also be the same thing as what I square arrow. Just so you have to take into all this one here. When you are doing your calculation. So this question is here. Calculate the power delivered by a three-phase line if the voltage and the currents are 132 kV volts and 60 amperes. So here we are being asked to calculate. Now let us write. So let's solve the first one here. Question one. Let's solve it here. You see that power, they have to calculate what power. Power is measured in watts. The unit of power is what is watt. Delivered by a three-phase line. If the voltage, the potential difference here is what is 132 kilovolts, right? Now this kilo also is about 10 power 3, so which also is about 132 times 10 power 3 what volts, right? Then our I is what? I is 60 what amperes, right? Now, yeah, remember P equals to what? Work over what? Work over time, right? Now, but here, remember, work equals to what? DQ over what T, right? Now, but yeah, they did give us time. Remember, Q is what? Q is what? VIT or T, right? Comes to here. So if you check very well, they gave us voltage and they gave us what amperes. So this is what we are actually going to use. So we are going to use P equals to voltage times what current. Do you understand? Voltage times current, because they said we should calculate what the power. Now they gave us what the voltage and we know what the amperes. So just for us to substitute here and calculate it. Here we have 132 exponential what 3 times what the 60 what amperes. So let's do the calculation. Then the calculation here we have 132 132 132 exponential what 3 times 60. Here we have 97920 So we're going to be what watts. So but now let's convert it to a standard. 1 2 3 4 5 6 so it will be 7.92 exponential what 6 watts. That is the what answer. Do you understand? As easy as that. So let's go what question 2. So let's go question 2. A 350 watts electric cooker is to be used on 20 volts means circuit. Calculate what the current. So yeah, my power is what? My power is 350 watts. My power here, my P is equal to 350 watts, right? And they gave us volts. The volt is what? Potential difference in volts. You are 200 volts, right? Let's say we will calculate what the current, right? Current, which is what you are looking for. So we are using P equals to VC, right? V. So you're supposed to be VI. VI, yes, correct. VI. So you're supposed to be VI. Yes, VI. So if you want to make I the solid formula here, you need to write P over what V, right? So you have now what 350 watts over what volt is what 200 volts. So what will be the answer here? So you have 350 divided by 200. You have 1.75 volts. You amperes. Remember, it is what it is in amperes, right? So let's look at what question 3. Look at what question 3. They say that a lamp is marked 222 volts and 60 watts. Calculate the energy it would consume when it's connected to a 22 volt source for 2 hours. Do you understand? So my volts, which is what charge difference is what 222 volts here, right? My power is what is 60 watts, right? Now they're asking us to calculate the current. Yes, calculate the energy. Calculate the energy W. Calculate the energy W when it is what 2 hours. So you have 2 hours. 2 hours. So remember we have to convert this one to what seconds. Now when you have hours, you have to multiply 60 times 60, right? So it will be 2 times 60 times 60. So you have 2 times 60 times 60. Here we have what 7200 seconds. So now let's see how we can actually solve this in here, because they're asking of the work done. Do you understand? They're asking of the work done. Remember, power equals to what? Work over what? Time, right? Over time. So because they're looking for the work done here. So you can easily use this formula here. So if you want to make work the solid formula here, which is the energy, right? W equals what? P times T, right? So it means that this question we don't really need what the voltage here in before we can calculate what the work done, because here I already have what my power and I already have what my time. So going to be 60 times 7200 seconds. So multiply it and go what get your answer. So here we're going to be 60 times 7200. Here we have 432,000. We got to be, which is what joules. 1 2 3 4 5. So it will be 4.32 exponential what 5 what joules. That is it. So you can see how easy it is. But there are some other problems which you cannot go in this class here. So as time moves on, as you get closer to your exam, most of these questions will be solved. You get. So, but please, we are trying to get to 4,000 subscribers as soon as possible. Please kindly help us to get to 4,000 subscribers by subscribe if you have not done that, liking and commenting, because this is what make YouTube to like spread this video to other places like you look for this kind of content. So your like and your comment will help this video to get visibility on YouTube. Do you understand? And another thing you can do to step further is what? Share this video with your friends who are also writing Jamb. Jamb, you understand, that is doing mass chemistry, because for this mass chemistry and physics video that will help you pass your Jamb very well. The goal is that you should write your Jamb one and get your desired score, so I can gain admission into your desired university, into the desired department or course you want to study. Do you understand? So that is the goal of what this YouTube channel. Do you understand? So please, as I'm trying to help you to produce more video that will be of help to you, please kindly help us to get to 4,000 subscribers, and I will be grateful for that. So we have come to the end of this class. So let me give you some questions for you to try. It's going to be assignment 2, because I've already given you assignment 2, and so you're going to do what? Assignment 2. So let's take the assignment now. Okay, so this will be your assignment 2. So question 1, question 2, question 3. And now some of you will say, Kem, Chris, you didn't do something like for us. That is the reason why as a student you need to think very fast. You need to think very fast. When you see what a question, how can you solve it? So you draw the knowledge of what you already know before. These are registered, they are connected to what in parallel. So you have to do the parallel calculation. Then they give you amperes. They say calculate the rate, that is calculate the power which energy is used in taking industrial by. So just look at the question and answer the question. You get. So if this video is helpful, please leave a comment section that this video is helpful. I'm so grateful that you stick to the end of this video. I wish you success in your upcoming exam. Please, we are trying to get to 4,000 subscribers. Please kindly help to like, subscribe, and share with your friends so that they too can be part of this class and part of the world community. Thanks for staying to the end of this video. Please, we also have some other videos on mass chemistry and some other topics in physics. You can go check them out and study them too.